Hi, welcome to Rocks and Minerals Rock with Miss Bailey. Any point during this video, you're welcome to pause it, go back, and rewatch it so you get all the information, but I will be going on and not pausing as I do it. And this lesson, I expect you to be able to learn to identify and compare the key traits or properties of rocks and minerals, and also learn to correctly pronounce the names and types of rocks. Listen for these key vocabulary words. The first thing I want you to do is to take your graphic organizer and fill out that first stop. You'll want to pause the video, fill out this top part of what you know about minerals and one thing you'd like to know about minerals, what you know about rocks, and at least one thing you'd like to know about rocks. Now that you've recorded your own information, let's start talking about minerals and rocks. Minerals and rocks are naturally occurring solid substances. Solid means that if you push on it, it will hold its own shape. This word right here, solid. Okay, think about water and the difference between water and a rock. Water is a liquid. It is not solid. It doesn't hold its shape. Rocks are found all around us, and we use them a lot in our building materials especially. All rocks are made up of mixtures of different minerals. And minerals are the basic building blocks from which rocks are made. So I'm going to turn to actual building blocks to help us understand this. Think about this as a mineral. You can see that our mineral is made out of specific shapes and colors that are all the same. All of these are nice bright orange. Okay, here's another mineral. Again, all the pieces within it are the same shape, same color. They might be arranged a little differently. Here's another mineral model for us, and here's another mineral model. Let me put all our mineral models out here. Notice each different piece is completely made of the same substance or material, the same color, the same size, same shape. Each of these represent our building blocks or minerals that together, if we combine these together, we would get a rock. A rock is made by combining different types of minerals together to get those rocks. And sometimes you can identify the different minerals within it, and sometimes it's hard to tell exactly what's in there. Minerals, we're going to be talking about first. Minerals have special properties that rocks do not. First of all, as you could tell from looking at our Legos, color is important when you're talking about minerals, not as much as rocks. We identify different minerals based on their properties or characteristics. The first one is hardness. Hardness is a measure of how hard a different mineral is. For example, talc, gypsum, and other minerals like them are very soft minerals. They are softer than your fingernail. For example, this is sulfur. Sulfur is a very soft mineral. I can scratch it with my fingernail and you can see it's come right off on my finger, that little yellow powder right there. Sulfur is a very soft mineral. However, I turn to a mineral that is a little bit, and I take if I take my sulfur and try and scratch one of these things here, for example, I have a piece of glass on a mirror. I can try and scratch my mirror with my sulfur, but it's not going to do anything except bleed itself, because this is too soft, not soft, hard enough to scratch on our mirror. And I can turn to, say, calcite right here, found right here. I have a piece of calcite right here. Calcite says, according to this chart, that it is harder than your fingernail, but softer than a copper penny. So here's my calcite, and I'm going to take my fingernail and I'm going to try and scratch it. And I can sit there and scratch at it, but I can't make any marks on this calcite. See that? Can't do it. But if I take the corner of my calcite, look closely, see this? It scratches my fingernail. That means my fingernail's softer than the calcite. But if I take a piece of copper, now I don't have a penny, but I have this copper bookmark from Chile. I'm going to take this little corner of it, and you can see that this little corner of copper can scratch our calcite right here. If I keep that in contact. Copper is a very soft metal. Okay, it did work earlier. And you can feel it more than you can see it, but I can feel these scratches on here from the copper. Copper is able to scratch calcite. An iron nail is harder than calcite, so the nail can easily scratch into it. See that right there? So this is harder than calcite. We can look at these other other minerals to identify them as well. The one other one I have here to show you is quartz. Right here I have a quartz crystal. And we'll talk more about the shape of it. But a quartz you see down here is one of the harder mineral types. It means it is harder than all these things. So I could scratch my fingernail again with quartz, and it will scratch it right away. I can scratch copper, although I don't want to. I can scratch glass. And so quartz is here, and glass is here. So here, we'll look at a fishbowl. This is made out of glass. I can take my quartz crystal, and I can scratch it and leave a mark. That's permanent, because this is harder than the glass, this mineral. Can you think about when this might be useful? Okay, hardness is one of the properties of minerals we look at. The other one is color. Here are a whole bunch of different minerals, all different colors. I've already showed you some of them, and I'll name the other ones for you. Okay, so our first one I already showed you is calcite. It's a very white, almost kind of clear mineral. I also showed you quartz already, again, much more clear mineral. This is not gold, it's called pyrite, often called fool's gold. People think it looks like gold. This is fluorite. It's got a kind of greenish blue texture within it, kind of cloudy. Sulfur I showed you is a softer one, it's very yellow. And mica is this black one here, it's very shiny. Little pieces of it do come off, so be careful if you're looking at these samples in light. All of those are minerals, and they all have a very different color. It's easy to identify. I'm going to continue to show these as we look at our screen. They also have a crystal structure. If you look closely at this quartz crystal, I can actually count the number of sides. I see I have 1, 2, 3, 4, 5, 6 sides. That means it is a six-sided or hexagonal crystal shape. The quartz also has a very square-edged, nice straight edge shape to it. It's more like this kind of one of these slanted shapes here. It's kind of a box to it. This is another example of quartz. You can also see the square crystal structures within it. You can't always easily see the crystal structures. Sometimes they're very small. Sometimes it's kind of hard to see them. But a lot of minerals have crystal structures. Of course, their appearances are different in their shapes and textures. Mica is a very soft and smooth mineral, versus pyrite here, which is a very soft, rough mineral. And this is a chalky mineral, that's sulfur. They have different patterns of shapes within them. You can see different patterns within these. And the last one is smell, which is my favorite. Many minerals don't have a distinct smell. I do know sulfur does. If you smell it, it actually smells kind of like rotten eggs or like fireworks that have been lit off. A lot of fireworks that contain sulfur within them in the gunpowder. That has a very distinct smell. There are over 600 different minerals found in Utah. Take a moment to pause this video and look through at these examples here on the screen to see where they are found in Utah. You'll want to note the name of the county as well as the picture and the key over here that'll tell you what that picture means. Okay, make sure you get at least 3 examples down. Sorry about that. Take 3 examples down. So look closely and note down at least 3 examples of minerals found in Utah. Okay, let's talk about rocks. We already know you wrote down about what you know about rocks. Rocks, as we said, are mixtures of different minerals. Okay? Remember our Lego. These are our rocks, mixtures of all the different minerals within there. Sometimes the individual minerals within the rock are easy to identify, and sometimes they're really small and hard to see. For example, within this rock, you can easily see the different parts that are in it, and we could identify the different minerals. In fact, inside of this rock, this is granite from here in Utah, we can see within it the mica, like I already showed you. There's little bits of mica pieces in there, as well as quartz within this rock. Together, that makes up this granite rock. We'll talk more about that granite in just a moment. Rocks are identified by properties just like minerals, but we use different properties. Mostly they're based on how they look or how they feel. There are 3 basic types of rocks. Hopefully you already identified them. Say them with me. They are sedimentary, igneous, and metamorphic. Let's talk about each of these types together. Sedimentary rocks. Sedimentary rocks are made from sediment or little tiny pieces rounded that have been ground down together and then get cemented. Little pieces of rocks get ground down, then they get cemented together permanently or glued together in a permanent way. Sediments are cemented or glued together by compression forces or squeezing and pushing of those sediments as they layer on top of each other. Sedimentary rocks are often very sandy. You can see the particles within them. Sometimes you can see definite layers, and those particles are very rounded because they've been ground down in sediments. Here's some examples of sedimentary rocks. Here's an example of a conglomerate. This is called conglomerate. You can see the different pieces that have been squished and squeezed in together, glued together within the conglomerate rock. Here's an example of limestone. Limestone has a little bit of a sandy feel to it. You can't really see the layers within it, but I can feel those sediment that were compressed together. Here's a piece of shale from right here in Utah. Again, I know it's layers of sediment, and I can see some of the layering here. And you can see this piece, it breaks right apart. Sedimentary is one of the softer rocks. And these pieces, it's a smooth rock, but I can still find those little gritty pieces easily, especially as it breaks apart. The last piece of sedimentary rock I'm going to show you is sandstone. As the name implies, it's made out of sand. In fact, you can hear little pieces of sand falling off of it. It's a very rough, made out of sand rock. This is also from right here in Utah. I collected myself. Those are sedimentary rocks and our properties. The next type of rock is, you guessed it, igneous. There's the names of the sedimentary rocks in case you need to see how they're spelled. Igneous rocks are rocks that are made when magma, or lava as you often hear it called, cools and hardens into rock. It's magma if it's below the surface of the earth. If it comes above the surface of earth, we call it lava. When those rocks, that magma or lava, cools down and hardens, it becomes an igneous rock. And you can easily tell what an igneous rock looks like because you'll often see large mineral crystals within it. You'll see bubble holes, or it will be glass-like or very dark colored. Here's some examples of igneous rocks. As you already saw, this is our granite. Remember we pointed out the minerals within it? This granite was formed because these little minerals within it got melted down within the earth into magma, and then they erupted to the surface of the earth as lava, and it hardened into these rocks. Here's another example. This is called obsidian. Obsidian, you can see, is very shiny. It's very glass-like. It's very dark in color, but you can see within it these little white speckles. Can you see those speckles within there? Those are other minerals that were mixed in as it got melted down into the magma soup of minerals. Here's another example of a igneous rock. This is basalt. Again, it was within the earth, got melted down, and then came to the surface in lava and hardened into basalt. And the last one is one of my favorites. This are two different rocks called pumice. Pumice has a whole bunch of air holes within it. The bubbles of gas that got melted down within it were trying to escape, but they didn't escape before the rock hardened. And so those little air holes within it make this a very, very light rock. In fact, it is so light that when I take a cup of water and drop it in, you see that rock there? Our pumice stone will actually float in water. If I drop in, say, my obsidian, it goes right to the bottom. No floating there. I can drop in my basalt, no floating there, but my pumice is right here, floating on the surface. And this one is there, floats right up there as well. Those are our igneous rocks. Our last type of rock to talk about is metamorphic. There's the names of the igneous rocks. Again, if you need to write, you'll need to write those down and draw a little picture. The last type of rock is metamorphic. Metamorphic rocks are combination rocks. It's when an igneous or sedimentary rocks get deep within the earth and there's a lot of heat and pressure applied to them, and it causes the minerals within them to change their shapes and their positions within it, and it makes these changed rocks that get melted. And sometimes you'll see them with sparkly layers within them or wavy lines that look like they have pages to them, or bands. Here's some examples of those types of metamorphic rocks. Let me show you the names before I forget. Okay, the first one we have is marble. Here's an example of marble. This is white. You can see that shininess in there, that sparkling layers. And here's another little piece of marble. I like this one because you can actually see some of those layers within it. See the darker spot and the lighter spot and the darker spot. This marble has been layered. And this is gneiss. Yes, it's that one with the G in the front of it. We say it is gneiss, and you can definitely see the very distinct layers and bands within this metamorphic rock. This is another piece of gneiss. Different shiny parts to it, different banded layers. I don't have examples of schist to show you, but those are gneiss and marble. And that concludes our discussion on rocks and minerals.